Hi, this is Chao from Cornell University. Today I will present our paper, Mathemyths. Leverage large language models to teach mathematical language through child AI co-creative storytelling. Thanks to my collaborators from the University of Michigan, Xuechen, Katherine, Soobin, Chi-Lin, and Ying. Mathematics is a fundamental building block in children's early education and a strong predictor of their future achievements. Particularly in early childhood, mathematical learning is not just about learning to count or calculate, it also emphasizes the ability to understand and apply mathematics language such as half, equal, estimate, and so on. Children often learn those mathematical words through everyday conversations with others, and one effective way is to engage children in joint storytelling, through which abstract language becomes more tangible and engaging for young learners. Typically, this story-based learning approach encourages children to engage in dialogues within a storyline. They understand and practice math terms with guidance from a skilled individual. However, such a one-on-one engaged storytelling session is logistically infeasible given the limited resources most educational institutions and families face. But as our previous research has shown, in the company of AI partners, children can now independently enjoy creative storytelling activities. So our question is, how might we design AI partners to engage children in joint storytelling activities for the sake of learning and practicing math language? To answer the question, we applied two educational principles from HCL research, learning theory, and the common core state standards for mathematics. Overall, the system should adhere storytelling to a question, feedback, scaffolding framework, and teach math language through exposure and practice with explanations. Now, let's move forward to see how these two principles demonstrate in our system design. Initially, the system allows a child to customize a main character and a story setting, and the main feature is to collaboratively engage in storytelling by alternating turns with the child through voice interaction. It contains four main features. First, the agent in our system continues the story by utilizing mathematical language based on the children's input. Let's see a story excerpt.
Lucy and Nick decided to ask for help from Lucy's father, Mr. Bamboo. He then added, "You must also find the halfway point, which is half of the total steps, that is, 50 steps from the start."
After story continuation, the agent will also provide in-context math word explanations to enhance the child understanding.
In this context, half is when you split something into two equal parts, like splitting 100 steps into 50 steps.
After that, the agent will generate a question to inspire children to continue the story and practice using math words.
How will Lucy and Nick find the halfway point?
Lucy starts at one end, Nick starts at the other, taking equal steps.
Besides, if the child fails to continue the story, the agent will rephrase the question and provide hints to scaffold them. For example, when the child says, "I don't know," the agent will rephrase the previous question and get the child to answer by providing more details. We engaged in an iterative design process by evaluating the two main features of question generation and story continuation. The results showed our finalized prompting methods for question generation can perform comparably with humans in readability, inspiration, story relevancy, and math language relevancy. While in story continuation, our finalized prompting method is also comparable to human performance, especially in preferences, creativity, and math relevancy. After refining our system, we engaged in a between-subject user study with 35 participants aged 4 to 8 years old, comparing our system to skilled human partners. We are interested in children's acquisition of target math vocabulary, the quality of the stories they create, and their levels of engagement and enjoyment throughout the process. We are also interested in how children at different developmental stages interact with our AI agent. So, during analysis, we divided the child participants into a younger group, ages 4 to 5, and an older group, ages 6 to 8. First, the results showed children of all ages can achieve similar improvements in math language testing scores by interacting with our system, compared to interacting with skilled humans, and even better, by looking at the scores in detail, we found children can only improve their understanding of the word definition through interacting with our system. This could be explained by the better performance of the AI agent in improvising in-context math explanations. In terms of the engagement level, when interacting with our system, children responded over 95% of the questions posed by Mathemyths, with their responses averaging between 6 to 10 words in length. However, children tended to be more responsive and provided longer answers to questions asked by the human partners. But these differences are mainly in the older group, which could be attributed to children's developing understanding of AI's capabilities and limitations. Specifically, previous research has identified that older children were more inclined to seek factual information from voice assistants, while seeking personal information from humans. Regarding the story creation performance, children performed similarly across different conditions and age groups. Interestingly, a younger group performed on par with their older peers when interacting with Mathemyths, despite younger children's presumably less developed language ability. This is attributed to our scaffolding features, which elicit younger children's responses and engage them in back and forth interactions around one question. Lastly, though no difference, children showed a more favorable reaction to storytelling with a human partner in terms of enjoyment and comfort level. However, they slightly favored the idea of having our system as a reading partner and expressed interest in reading another story with it. So throughout the design process and user study, we conclude several takeaways. First, we observed several design challenges of LLMs for education technologies. We found LLMs as design materials require more iterative prompt engineering optimization, given the unpredictability of outputs compared to specialized machine learning models. Controlling LLM's performance in a fine-grained manner, such as citing word limitation or adhering to structural directives, is also challenging. Besides, it is also important to bear in mind that the hallucination phenomenon of misinformation generated by LLMs could also be detrimental to learners. We also derive several design applications for future child AI co-creative storytelling systems. For example, the generated question could be more adaptive to children's unique features, like existing knowledge levels. Providing multimodal creativity supports like AI generating illustrations is also a good future direction to engage children in such a create-learn process. Lastly, we also encourage future researchers to design embodied interactions for children in this context. So, In conclusion, we expect AI could provide a unique interaction opportunities in the near future. These interactions, while different, could supplement children's everyday human interactions. Yeah, this concludes my presentation on our work. Thank you for your attention and engagement.